Now that we have seen the algorithm and pseudocode that we can use for implementing selection sorting algorithm, it's time for us to go ahead and write the programmatic implementation of same thing using JavaScript. Okay, for that again anyway, I'm going into this sorting folder that I have created, and I'm going to create a new file by the name selection sort.js. In this, let me create a class selection sorting. Okay, now let's write a separate function selection sorting in this. Okay, this will take a array by the variable name arr. Okay, now as part of the algorithm and pseudocode that we have written previously, we have to find an appropriate value for each and every position in the array. So how will we do that? We will simply be running a loop. For that, let me initialize a loop here. Let I equal to 0, I less than array dot length I plus plus. Here, if you remember clearly, there are two parts in the array, right? One is sorted part and the other is unsorted part. We will have to find an appropriate value from the unsorted part of the array, and we have to insert it into this ith position. So to find out that position which has the next minimum value, what we have to do, we will have to store that reference in some variable. For that, I'm defining a variable called let current index. So whatever the variable that we are starting, right, I'm assigning that itself as a, that cell itself contains the minimum value when I declared this current index. Okay, now what I will do, I will have to compare the value at this current index with the unsorted values in the array. So for that, what I will do, I'll simply write another loop for let j equal to, remember, we should always start with I plus 1th index, because ith index anyway we have the access in the current index value, and all the indexes before I are anyway sorted. So it's always better to start with the index I plus 1. Okay, and we should run this loop till the end of the array, that means the last index, which is nothing but array dot length, and in each and every step we will have to go to the next index. Okay, while running this one, what we did, we actually compared the values at current index with the value at the index j, right? At any case, if the value at jth index is smaller than the value at this current index, then we updated the current index variable with j, because that could be the possible value that can go into ith position. Okay, for that we will simply compare a of arr of current index is greater than arr of jth index. Then we will simply update the current index with equal to j. Okay, by the time we complete this outer inner for loop, we will have the position of the element that should go into this ith position inside the variable current index. So all we have to do is swap it. For that swapping logic, I'm declaring a const temp value. I'm storing the value of a of I. Okay, now I'm filling this, not a, it is arr. Okay, I'm filling this arr of I with the value arr of this current index, which contains the suitable value for that specific position. Once this is done, arr of current index should whatever the value we have at the ith index should go on to the value at current index, so which is nothing but temp here. Okay, we will simply be assigning it with temp. Okay, if you observe the bubble sorting algorithm with the selection sorting algorithm, now you should be able to identify the difference clearly. In bubble sorting, inside the inner for loop, we compared and swapped then and there itself. Okay, by doing all those swapping operations, by the end of the inner for loop, we were able to push that specific largest value into the end of the array, right? But here we are simply comparing the values and we are simply storing that specific position. Later on, we are filling that position with the appropriate value here. Okay, that is the major difference between selection sorting and bubble sorting algorithm. Now let's go ahead and initiate the object and call this function and make sure everything is working as part of as per our understanding. For that, let me say const, let me initiate an object ss equal to new selection sorting. In this ss dot selection sorting of, let's say I want to sort the values 1, minus 20, 11, 3, let's say 23. Okay, if you see here, I am not returning the sorted array in the end, I believe, but we will have to return it in the end once we sort the array. Okay, I am returning it. Now let's, whatever the value that I am returning, let me capture it into some variable, let's say sorted array. Okay, in the end, just to make sure, let's print it. Okay, now let's try running this program and see if the logic is actually able to sort the values in the ascending order. For this, what I will do, node, it is, the file name is selection sort, but it is inside the folder sorting, right? Sorting selection sort. Okay, do you see the array is sorted in the ascending order? Okay, even if you give like hundreds of values in the array, you should be able to see the array, resulting array that contains the values in the ascending order. Similarly, if I have to modify this to descending order, let me copy paste the same function and modify the function name to this, and let me change the comparison sign to less than from greater than. Okay, because we will have to fill with the largest value that is applicable or suitable for that specific position. So we will be modifying the operation to less than. Now if I call the same function, instead of selection sorting, we should see the array sorted in the descending order. Let me run it. Do you see here 23, 11, 3, 1, minus 20. Okay, this is how selection sorting algorithm is actually implemented in JavaScript.